Çagri. I'm very glad to be here actually. Thank you for this event. I'm here. And today I'm going to talk about my PhD thesis. Actually, I finished my PhD about 2.5 years ago in Southampton. And my main supervisor was Professor Tolga Bektaş from University of Southampton. And I had two supervisors. One is Ola Jabali from Politecnico di Milano. And second one is Gilbert Laporte from HEC Montreal. And actually, the main title of my PhD is Heterogeneous Location and Pollution Routing Problems. Actually, before talking about my research problems, I would like to give a brief introduction about the main research topic, which is the vehicle routing problem. Actually, there is an illustration in here about the VRP, vehicle routing problem. Actually, in the classical version of this problem, there is one depot and several customers, and the aim is to construct routes for satisfying the customer demands. And also there is, in an extension version of the VRP, there is a time windows constraints. It means that some customers has time windows in here. For example, the vehicle can only visit customer E between 10 a.m. and 11 a.m. This is the time window constraints. And the parenthesis shows the customer demands in here. And actually in the classical version, there's one type of vehicles, homogeneous fleet type, and it's called as the VRP, the vehicle routing problem. Actually, we considered an extension of the VRP, which is called as heterogeneous vehicle routing problem. And in this version, instead of one vehicle type, there are more than one vehicle type. And for example, in this illustration, I put two types of vehicles. And each vehicle has a capacity. For example, first vehicle has 10 tons, and second one has 15 tons in here. And for example, the first route, including customers A, B, and C, was served by the second type of vehicle, and the second route is served by the first type of vehicle. Okay, and this is called as heterogeneous VRP. Yes. Now let's look at another extension of the VRP. Actually, in optimization problems, the facility location problem is also well known. And actually, about 60 years ago, facility location problem and the VRP, vehicle routing problem, has combined, and the location routing problem has arisen. And actually, in this version of the problem, there are actually three decisions to optimize. First one is the location of the depots or warehouses facilities. And there are some potential locations in the region network, and we decide to open one of them or several of them. And for example, in this illustration, we open depot 1 and depot 3, and depot 3 is closed. And the second decision is the assignment of customers to depots. And for example, we assigned customers 1, 3, 9, and 10 to depot 1. And the third decision, actually, routing part. Firstly, we decide on which facility we open. Then we assign customers. Then it's time for the routing part. Yeah. And now let's look at the green part of this problem, green logistics. Actually, freight transportation, there are actually many sources about the impact of freight transportation on greenhouse gas emissions. And one is that the European Environment Agency. And 2 years ago, they reported that about 17% of the total greenhouse gas emissions is coming from the freight transportation. And actually, in my thesis, we focus on road freight transportation particularly. And actually, these CO2 or greenhouse gas emissions are proportional to fuel consumption of the vehicles. Okay? And actually, fuel consumption is, in the road freight transportation, there are many actually parameters, and they are related with distance traveled of the vehicle, and the speed of the vehicle, and vehicle curb weight, vehicle load, and the slope of the road surface. There are many parameters actually, acceleration, deceleration, for the fuel consumption parameters. And now let's look at an extension of the VRP. Actually, it's called as the pollution routing problem. My PhD supervisors, Tolga Bektaş and Gilbert Laporte, actually introduced this problem. Almost 7 years ago, they published a paper about this problem actually, which is an extension of the classical VRP with time windows, and the name is pollution routing problem. Actually, the aim in this problem is to consist of routing vehicles to serve a set of customers that are a customer set in the region, and optimize the speed on each road segment, on each arc between customers. They look at the speed, and their aim is to minimize a function which includes fuel cost of the vehicle, emission cost, CO2 emissions cost, and the final driver cost. Okay? This is the main aim of the PRP paper. And actually, in this paper and in my thesis, actually, we use fixed parameters. And as I said to you, I consider heterogeneous. Heterogeneous fleet of vehicles. I think it's better to use the microphone. Can you hear me easily?
Yeah.
Perfect. Actually, these are parameter values of 3 types of vehicles. For example, in here, I consider 2 types of light duty. They are not same, but they are similar parameters. And 1 type of, and actually each vehicle has a fixed parameter. For example, they have curb weight and payload, maximum payload, and vehicle fixed cost. For Dale, actually, we convert with simple conversion. We use simple parameters, and engine friction factor, and so on. And if you actually use a function, actually there are many functions in literature about the fuel consumption. And actually, in general, we get a U-shaped curve. In general, U-shaped curve about fuel consumption and speed of the vehicle. And actually, there's a trade-off in this part. And for example, in congested cities, if we are working in the urban road freight transportation, if we are in the city logistics context, it's better to drive as fast as possible, because in general, the optimal speed around 50, 60, 70 kilometers per hour for these parameters actually. But in city centers, the vehicle speed is maximum 40 or 50 kilometers per hour. That's why it is better to drive as fast as possible. But on highways actually, it is better to drive more slowly. With this parameter setting actually I'm talking. Because it's not always easy. It's not simple in practice, because in the highways, drivers have to drive at the traffic speed, and also if the drivers slowly drive the car, the companies will have to pay more salary to the drivers. Actually, there's a trade-off between fuel consumption and driver cost. We look at this trade-off in my PhD. So, okay, now let's look at my thesis, the main topics. Actually, we'll look at three main research problems from the thesis. Actually, it's mainly based on the vehicle routing problem, which is an extension, heterogeneous vehicle routing, and facility location problem. It's the second part. And also we'll look at the vehicle emissions and fuel consumption. Actually, I had 5 main papers in my thesis, and in the first 2 papers we looked only at the classical version, heterogeneous vehicle routing. Then in the third problem, actually I will talk about each of the chapters very briefly in the next slides. We look at, in the third paper actually, we look at the combination of heterogeneous vehicle routing and facility location. And in the fourth one, we look at the combination of these 2 problems, and my actual final chapter combines all of these 3 problems in one paper. Okay. Actually, there are some examples in practice about these considered problems. Yes, actually, I looked only at the theoretical side of these problems, but when we look at the real-life examples, there are many companies. For example, FedEx, which is one of the biggest one in the country. And actually, they aim to serve customer demands within 2 days, 2 business days, which we can consider these as a time windows of customers. And actually, they have more than 375 airports. There are many depots or facilities for the company. And they have around 650 heterogeneous aircrafts, different types of aircrafts. And they have almost 50,000 vehicles with different sizes. And they have operating facilities and air express hubs in the world actually. And actually for the green part, for the pollution part, I put an example in here. For example, between 2005 and 2012, they achieved 22% fuel efficiency by using hybrid trucks. They aim to be more green in transportation, and they have several aims actually. This company, actually, most of the companies nowadays have aims for the green transportation to reduce the CO2 emissions. And for example, they say in 2 years' time, actually by 2023, they would like to reduce vehicle emissions by 30%. This is their aim, and to increase vehicle efficiency by 30%. And until 2030, they aim to get 30% of its fuel from alternative fuels. Yeah, this is an example. Okay, now let's look at my general research contributions of my thesis. Actually, we aim to analyze and investigate heterogeneous routing problems. These are one of the main aims. And we aim to introduce new variants involving aspects of depot location, facility location, fleet composition of the different types of vehicles, and external environmental objectives. And actually, to solve these kind of problems, we aim to develop powerful metaheuristic techniques. I use several heuristic techniques. I'm going to talk in the next slide. And we, in our computational part, in the computational experiment part, we aim to derive several policy and managerial insights actually. Yeah. These are my main research contributions in my thesis. And now look at the solution methods that are used in my thesis. Actually, it's based on genetic algorithms, evolutionary algorithms. It's one of the common heuristic methods in the world actually. And it's also called as evolutionary or genetic or population-based search heuristic techniques. And actually, almost 10 years ago, a local search technique, which is called as adaptive large neighbor search, has developed for solving many variants of the VRP, weak relative problem. And actually, this is one of the powerful heuristics nowadays for VRP problems, weak relative problems. And actually, in my thesis, we combine these two successful heuristic techniques into one algorithm. And my actually heuristic based on genetic algorithms and adaptive large neighborhood search algorithms. Okay? Population search and local search. We combine both of them. Actually, there's an example in here about the local search technique. At the beginning, actually, we obtain a feasible solution for the considered problem in the papers. Okay. We can actually use many types of methods to construct the initial solution. And then, actually, we apply local search method to obtain better solution than the first feasible solution. Actually, there are some techniques, there are some operators to remove customers, and then there are some procedures actually to insert the customers into better place to minimize the cost. Okay? This is a simple illustration of the technique that I used in my thesis. Okay, now let's look. Okay, now let's look at the first paper of my thesis. I need to be quick. Actually, we used a hybrid evolutionary algorithm, and we combined the both of the parameters, both of the techniques. And actually, we considered 4 types of variants of the problem. Actually, this is our contribution is to develop a method which can solve 4 types of VRP within a same parameter setting. Actually, we compared ourselves with benchmark instances in the literature with other papers, and we improved 75 solutions, and we matched with 102 solutions. And now let's look at my other paper, my second paper. In this paper, actually, we combine heterogeneous VRP with facility location problem. And in here, actually, we have 3, for example, we have several depots. We decided to open several of them, and then assign customers, and create and construct the routes, and select the suitable vehicle type for each route. This is my second paper. Actually, in this paper also we conduct extensive computational experiments about my algorithm, and we compare our solution with the Cplex. We actually propose a mathematical formulation. We officially propose a mathematical formulation and solve it by Cplex, and we solve the problems by heuristic algorithm. Actually, for small size instances, we almost get the optimal solutions with the algorithm. But for the larger size instances, I mean for 100 customers in the region, of course, our algorithm obtain better solutions than the Cplex. Okay? These are very technical computational parts in the thesis. And now let's look at the green part of my thesis. We combine fleet composition with the pollution aspect, actually. And in this paper, we consider 3 types of vehicles, and I just use their specific parameters to compute the fuel consumption in the paper. Actually, we mainly our main contribution in this paper, we demonstrated the benefit of using different types of vehicles in this paper. We have also many other contributions, but this is one of the most important ones. Okay? And in my actual final paper, we combine 3 problems in one paper, which in where we consider the depot location, fluid composition, I mean heterogeneous vehicles, and routing decisions on CO2 emissions of the vehicle in city logistic context or urban road freight transportation. And actually we considered a city with 3 zones, and each zone has a fixed speeds actually. And actually there's a trade-off between each zone, and we use the Manhattan distance grid in the network in my final paper, and we actually conducted many extensive computation experiments in this chapter to analyze the trade-offs and different versions. And for example, we look at three cases. For example, we think that in the first version, the customers mainly concentrated in the city center, due to the first case. And in the second case, most of the customers are located in the outside of the city center, in suburban areas. And maybe we also considered the customers are randomly located in the region. We look at the analysis of these experiments. Actually, we obtained several interesting insights, managerial insights. And actually, as expected, we see that the highest cost, the highest total cost are incurred when all customers are in the city center, because the cost of the depots are expensive in the city center, but if you put them in the outside of the city, it's more cheaper. So we find this with our computational experiments. And actually, we said to the companies, it's always preferable to locate the facilities outside the city center, and we quantified the cost and environmental benefits of using different types of vehicles, heterogeneous fleets. And actually, in another insight, we found that the capacity utilization of the depots are higher than the capacity utilization of vehicles, because it's always expensive to open depots than the vehicles or trucks. These are our main findings of this final chapter. And actually, from my thesis, we published 5 papers in several journals. And yes, this is it. Thank you very much.